Have you ever wondered how your gaming controller magically brings your on-screen character to life? How does a simple button press translate into a dazzling combo or a perfectly timed jump? It's a fascinating blend of hardware and software, a seamless process that makes complex interactions feel effortless. For any gamer, understanding this process can deepen your appreciation for the technology you hold in your hands. This content is for anyone curious about the tech behind their gaming experience. Whether you're a casual player or a hardcore enthusiast, you'll gain a clearer understanding of how your controller connects to your game, enhancing your overall gaming knowledge. By the end of this video, you'll know the journey a signal takes from your thumb to your character's actions. We'll cover how controllers send signals, how your console processes them, and how game engines bring everything to life. Let's demystify this magic. First, let's look at the controller itself. It's an input device designed to convert your physical actions into digital signals. Every button press, joystick tilt, and D-pad movement is a physical input. Inside the controller, these inputs trigger tiny switches or sensors, translating your actions into electrical signals that the system can understand. Controllers use both analog and digital inputs. Digital inputs are simple on/off signals, like a button press for "jump." Analog inputs, like joysticks, measure the degree of movement, allowing for precise control, such as how fast your character walks or runs based on how far you tilt the stick. Once the controller generates these digital signals, they need to travel from your hands to your gaming system. This is where signal transmission comes into play, acting as the invisible bridge. Wired connections, like USB, offer a direct and reliable data transfer. The electrical signals travel instantly through the cable, ensuring minimal lag and a consistent connection. This direct link makes wired controllers a favorite for competitive gamers who prioritize responsiveness. Wireless connections, such as Bluetooth, Wi-Fi, or proprietary radio signals, transmit data through the air. The controller encodes the signals into radio waves, which are then picked up by a receiver in the console or PC. While offering freedom of movement, wireless connections rely on stable signal transmission to avoid latency or interference. Once the signals reach your console or PC, the real magic of processing begins. This is where your commands are understood and prepared for action. The console or PC has a dedicated receiver, often a chip, that interprets these incoming signals from the controller. It decodes the digital information, recognizing which button was pressed or how far the joystick was tilted, and then translates it into actionable data for the system. The CPU, Central Processing Unit, and GPU, Graphics Processing Unit, are the brains of the operation. The CPU processes your button presses as game logic commands, while the GPU renders the visual response on screen. Together, they turn your input into immediate on-screen action, like a character jumping or a spell being cast. The game engine is the software framework that brings everything together, making your character responsive and the world interactive. Within the game engine, there's a crucial component called input mapping. This is where developers assign specific actions to different controller inputs. A jump button press is mapped to a character's jump animation, a joystick tilt is mapped to character movement speed and direction, and so on. This mapping ensures that your inputs trigger the correct in-game responses. Modern game engines also incorporate physics and animation engines. The physics engine ensures realistic interactions, like gravity affecting a jump, or objects colliding naturally. The animation engine handles character movement and expressions, making actions look fluid and lifelike, adding to the immersive experience. The magic doesn't stop at input. Controllers also provide feedback, enhancing immersion through rumble and haptics. Many controllers feature rumble motors or advanced haptic feedback systems. These vibrations and tactile sensations provide immediate physical feedback to the player, making the gaming experience more immersive. Feel the impact of an explosion, the recoil of a gun, or the subtle texture of walking on different surfaces. This feedback isn't random. The game sends signals back to your controller, telling it when and how to vibrate. It's a two-way communication loop that completes the illusion, making you feel truly connected to the game world. From the moment you press a button to the instant your character responds, it's a seamless and incredibly complex dance of technology. The intricate dance between hardware and software, from your controller's internal sensors to the game engine's physics, works in perfect harmony to deliver the immersive gaming experience we all love. As technology advances, controllers will continue to evolve, offering even more intuitive inputs and immersive feedback, pushing the boundaries of what's possible in interactive entertainment. The magic of gaming is only just beginning.